Good morning. It's January 21st, and this is your daily brief in science. Here's everything you need to know. A new approach targets Parkinson's root causes by using a design decoy called CS2 to lure alpha-synuclein away from the mitochondrial enzyme CLPP, restoring mitochondrial function and reducing brain inflammation in human brain tissue, patient-derived neurons, and mouse models. The study reports that CS2 not only improves mitochondrial health, but also enhances mobility and cognitive performance in several models, suggesting potential disease-modifying effects beyond symptom relief. Across multiple models, CS2 reduced harmful protein forms and restored neuronal signaling in cells exposed to alpha-synuclein clumps, while rescuing mitochondrial function and cellular structure in patient-derived dopamine neurons with familial Parkinson's mutations. Lead author Di Hu and colleagues emphasize that this strategy targets a root cause of Parkinson's disease, rather than merely addressing symptoms. The discovery signals a shift toward protecting mitochondrial health to tackle underlying disease mechanisms. Xin Qi and collaborators describe this as a fundamentally new strategy for Parkinson's treatment by focusing on disease drivers rather than symptoms. The study, published in Molecular Neurodegeneration, 2025, with DOI 10.1.186/S13024-025-00918-W, identifies a harmful interaction between alpha-synuclein and CLPP that impairs mitochondria and accelerates neuron death. This work points to disrupting the alpha-synuclein-CLPP interaction as a potential therapeutic target to protect mitochondrial and neuronal health. Researchers plan to move toward clinical trials within 5 years, aiming to optimize CS2 for humans, assess safety and efficacy, identify biomarkers, and translate findings to patient care. In a Parkinson's mouse model, 6 months of CS2 treatment improved motor coordination and spatial memory, restored CLPP levels, reduced alpha-synuclein clumps, and lowered brain inflammation compared with controls. A stunning infrared portrait from NASA's James Webb Space Telescope shows the Helix Nebula in high detail, revealing comet-like knots and fast stellar winds as a dying star sheds its layers. Located about 650 light-years away in Aquarius, the Helix Nebula has fascinated astronomers and earned comparisons to an eye, earning its reputation as a well-studied planetary nebula. The image captures hot gas near the central white dwarf colliding with cooler, slower gas, shaping the nebula's structure and illustrating gas recycling in the galaxy. The study highlights how dying stars supply raw materials for future generations of stars and planets, underscoring the importance of understanding stellar death and material recycling. Though called a planetary nebula, it has no connection to planets. It is the result of a star shedding its outer layers. A standout feature is the cometary knots, dense, dusty structures formed by interactions between hot gas and surrounding material. Color in the image conveys temperature and chemistry, with blue for the hottest gas near the white dwarf, yellow for cooler gas where hydrogen molecules form, and red at the edges for the coldest material and dust formation zones. Webb's observations build on prior Spitzer findings, revealing how complex molecules form in shielded regions within the nebula, including dark pockets amid glowing gas. The view emphasizes contrasts among hot ionized gas near the white dwarf, cooler molecular hydrogen farther out, and dust-enshrouded pockets where complex molecules may arise, signaling raw material for future planet formation. A new vaccine from the University of Georgia targets Candida auris, a drug-resistant yeast that spreads in healthcare settings and is labeled an urgent public health threat by the CDC. In mice, the pan-fungal vaccine generated protective antibodies and reduced illness and deaths in those infected. This approach builds on prior work showing protection against the 3 dominant fungal pathogens across multiple preclinical models, including non-human primates, and even vaginal yeast infections in mice. The antibody-driven strategy could serve as both a preventive measure and a treatment for acute or life-threatening C. auris infections. Key contributors include Karen Norris of the Immunology and Biomedicine Translation Team and researchers from UGA's Center for Vaccines and Immunology and College of Veterinary Medicine, with collaborators from Kaiser Permanente Southern California. The study, published in Vaccines, also involved Emily Rayans from the same UGA centers. Researchers emphasize the urgency of antifungal advances as drug resistance rises. If proven effective in humans, this vaccine could become the first to prevent pathogenic fungal infections, addressing a major global health threat highlighted by the World Health Organization. The work aligns with WHO's view of pathogenic fungi as a top global health threat and presents the vaccine as a potential first-in-class preventive option against diverse fungal infections. Contingent on successful clinical trials, the vaccine could move toward use in humans to prevent pathogenic fungal infections and tackle this WHO-identified threat. A Swedish study in JAMA Neurology links long-term air pollution exposure to a higher risk of motor neuron disease, including ALS, and suggests it may accelerate disease progression. Even at pollution levels common in Sweden, just above WHO guidelines, the long-term exposure raises MND risk by about 20% to 30%. The findings point to air quality as a potential driver of MND, even in relatively clean environments, emphasizing the role of reducing pollution for neurodegenerative disease prevention and outcomes. The study adjusted for several socioeconomic and environmental factors, but did not include data on smoking or indoor air pollution, a limitation not believed to fully explain the observed associations. Researchers frame the results as part of the broader puzzle toward understanding MND and advancing treatment and prevention. Funding came from multiple organizations, including the US CDC and Karolinska Institutet, with analyses based on Swedish registry data. The study is observational and cannot prove causality, though inflammation and oxidative stress from pollution are plausible mechanisms supported by prior work. Results indicate that nearby traffic pollution may have a stronger impact on risk and progression than distant pollution, though the exact biology remains unclear. Motor neuron disease comprises disorders that destroy motor neurons, causing muscle weakness, paralysis, and respiratory failure, with no cure. Exposure to 4 main pollutants was measured at participants' homes, with relative risk increases of 20% to 30% and stronger associations for the 10-year exposure window. The study analyzed 1,463 MND patients in Sweden, comparing them to 1,768 siblings and over 7,000 general population controls, using home-based pollution data up to 10 years before diagnosis. By examining pollution at each participant's home over 1, 3, 5, and 10 years before diagnosis, the association persisted even when comparing siblings, helping account for shared genetics and early life environment. A UK-led trial at Cambridge is testing whether limiting adolescents' social media use can improve mental health, a world first in this kind of experimental approach. About 4,000 Bradford pupils aged 12 to 15 will have a daily time limit on apps and a 21:30 to 7:00 curfew to assess effects on anxiety, depression, sleep, and social experiences. The project is led by Professor Amy Orban with Dr. Dan Luer and collaborators from the Bradford Center for Health Data Science, funded by the Wellcome Trust. Experts say the aim is to balance online safety with well-being, seeking interventions beyond simple bans to support healthy development. Feasibility runs are planned for spring and summer 2026, followed by a 6-week full study in autumn and winter 2026, with data analysis targeted for mid-2027 and publication in major journals. The trial includes a broad range of apps: TikTok, Snapchat, Instagram, Facebook, X, YouTube, Reddit, and LinkedIn, while excluding WhatsApp to preserve family communication. Results are expected in the summer and will be independent of the United Kingdom government's consultation on a potential under-16 social media ban. Participants will be compared to a control group using social media normally, with 6 weeks of observation to establish baseline and outcome differences. Primary outcomes focus on anxiety and depression, with secondary analyses tracking sleep, bullying, time with family and friends, and social comparison effects. The study will measure shifts in anxiety, depression, sleep quality, social interactions, well-being, and related factors to gauge social media's impact. To capture group dynamics, all students within a given year in a school will experience the same intervention. Experts say the findings could inform policy in the United Kingdom and beyond, given the lack of large-scale experimental data on reducing time spent on social media for under 18. This has been your Daily Brief in Science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.